I greet you, ladies and gentlemen, even as I introduce this topic. I believe all is well with you, even as I start this topic. I trust all is well with you, even as I come before you to share notes on the IS-LM model. Without much wasting of time, I'll go to my lecture slides, which I'm going to present to you. Hopefully, I'm going to cover a lot of content, but if I'm not able to finish, there would be a part 2 to these lecture slides presented in video format. Thank you so much. So we are covering the IS-LM BP model, but the BP part will just cover it intuitively. This presentation is based on a book by Gregory Mankiwi. It is based on a book by Gregory N. Mankiwi, or N. Gregory Mankiwi. So this is based on a chapter which is taken from a book entitled Macroeconomics by N. Gregory Mankiwi. But there is an illustrative example which I crafted for purposes of revision. We need to define what the IS curve is and its relation to the Keynesian cross model, and also the loanable funds model. We also need to define the LM curve and its relationship to the theory of liquidity preference. And then we need to explain how the IS-LM model determines the income and the interest rate in the short run when the general level of prices is fixed. The context is that in the long run, we know that prices are flexible and the output is determined by factors of production and technology. Unemployment is at its natural rate, the so-called natural rate of unemployment. In the short run, prices are fixed. Output is determined or driven by aggregate demand or aggregate expenditure. There is an inverse relationship between unemployment and the level of output in an economy. So when we are looking at the Keynesian cross model, in a simple closed economy model, in which income is determined by expenditure, we expect planned expenditures to be a summation of household consumption expenditures, investment spending by private sector firms, and government spending. And then the RY is the real level of GDP or real national income, which in the steady state is expected to be equal to actual expenditure. Any discrepancy between actual and planned expenditure leads to an unplanned inventory change, inventory investment changes. If actual expenditure is greater than planned expenditure, there are implications for that, and the reverse is true. Implicitly defined consumption expenditure is a function of disposable income, where the C on the left-hand side defines the dependent variable, which is household consumption expenditure, And the C on the right-hand side is just like writing function of. It's the implicit definition of consumption. That consumption is a function of disposable income, Y minus T, where Y is the real level of GDP and T is the level of taxation. And G is assumed to be exogenous. In other words, G is not related to changes in national income. And T is also assumed to be exogenous because these two, government spending and taxation, are government policy variables. They are not determined within our model of national income. So planned investment is also taken to be exogenous as well. So planned expenditure is simply the summation of consumption expenditure, which has been defined implicitly, as I explained, and then plus investment spending plus government expenditure in a closed economy. At equilibrium, actual expenditure is equal to planned expenditure. Actual expenditure is equal to planned expenditure. We write planned expenditure on the vertical axis and the real level of output or income on the horizontal axis. So this planned expenditure has got a vertical intercept because of the autonomous consumption component of the consumption function. As we saw in the simple Keynesian model, we're just building on what we've already covered in the Keynesian cross model. And then your I and G, they are also contributing to the intercept. Since we assumed that they are exogenous, your G is exogenous and your I is exogenous. So they just augment the autonomous consumption bit, just passing the planned or aggregate expenditure curve upwards. The slope of this function is the marginal propensity to consume, because the other variables are government policy variables. The other variable G is a government policy variable, and investment spending is taken to be exogenous. So if we draw the 45 degrees line, along this line, planned expenditure is equal to the real level of national income. At the intersection of the 45 degrees line and the planned expenditure function, which is our aggregate expenditure function, we attain equilibrium level of national income, as shown on the diagram. So if there is a change in government spending, for instance, if government spending increases from G1 to G2, this shifts the planned expenditure curve or the aggregate expenditure curve upwards from G1 to G2, because the PEs are just labeled the same way. At Y1, there is now an unplanned drop in investment because planned expenditure is increased. So at this original level of national income, inventories are declining very fast because people are spending more, or they are expected to spend more. So shops are beginning to take things which were accumulated in the warehouses because of the increase in government spending. And what does this necessitate? Firms have to increase output, which leads to national income rising towards a new equilibrium, which is Y2. So there is the government spending multiplier, which will be taking place. So if we solve for delta Y, the equilibrium condition is that y is equal to c plus I plus g, which is just a rehashing of something which we have already covered. It stands to reason that if the first statement is true, therefore delta y is equal to delta c plus delta I plus delta g in terms of changes. And there is no loss of continuity in terms of our analysis. But we know delta I does not really change because the investment spending is exogenous, but government expenditure can be varied by government. And consumption expenditure changes because there is that aspect of the marginal propensity to consume. When national income increases, we expect consumption expenditure to change as well. But what is the change in consumption expenditure? It's simply the marginal propensity to consume multiplied by the change in national income. So if the change in national income is, say, $100, and our marginal propensity to consume is 0.75, the component of the change in national income of $100, which is devoted to consumption, would be 0.75 multiplied by 100, which gives us $75. So out of every $100, $75 would be slated for consumption, household consumption expenditure, whilst the remainder, which is $25, will be distributed either to taxation or to savings or both, depending on how many leakages you have in your economic system, plus delta G. So if we collect terms with delta Y on the left-hand side of the equal sign, it means we take MPC multiplied by delta Y to the left-hand side, and then we factorize delta Y. We'll have 1 minus MPC multiplied by delta Y, which is equal to delta G. And then we can divide both sides by 1 over MPC, which means the change in national income is simply delta G multiplied by 1 over 1 minus MPC. Yes. So solving for delta Y yields delta Y is equal to 1 over 1 minus MPC multiplied by delta G. So the government expenditure multiply, the definition is that the increase in, it's an increase in income resulting from $1, we can say $1 million or whatever, $1 increase in government spending. In this model, the government purchases multiply equals delta Y over delta G, which is equal to 1 over 1 minus MPC. If we come up with a problem, if MPC is equal to 0.8, then the government spending multiply is simply delta Y over delta G, which is equal to 1 over 1 minus 0.8, which is 1 over 0.2, which is simply 5. So the government spending multiply is simply 5, or the reciprocal of the marginal propensity to save. So an increase in government spending causes income to increase 5 times as much, according to the prediction of the government purchases or expenditure multiply. So the question is, why is the multiplier greater than 1? The answer is that initially the increase in government spending causes an equal increase in national income. Delta Y is equal to delta G, but as national income increases, we expect consumption to increase, which increases national income further, which increases consumption further, which increases national income further, until we have got an infinite geometric series, which will be converging at a certain point. So the final impact on income is far much bigger or higher than the initial change in government spending, because the trigger of the rounds of expenditure contributes to sort of self-sustaining rounds until the process of the change in national income converges at the new equilibrium level of national income. An increase in taxation, initially the tax increase reduces consumption and therefore planned expenditure. If we maintain that our C is defined as C of Y minus T, so if we increase the absolute T, it will reduce our autonomous consumption component, thereby biasing our planned expenditure function downwards, which leads to an unplanned inventory build-up. So if there is taxation, people's disposable incomes go down, and planned expenditure, aggregate expenditure becomes subdued, leading to an accumulation of inventories, which results in a reduced output, and national income falls towards a new equilibrium of Y2, as shown on that graph. So if we solve for delta Y is equal to delta C plus delta I plus delta G, which is the equilibrium condition in terms of changes. Just generalizing from the equilibrium condition of absolutes, which is equal to delta C, since I and G are taken as exogenous. Here we are no longer experimenting with government purchases. Government purchases are now taken as given, and investment is also taken as given, since there is a variation in taxation. We are just experimenting with taxation in this economy. So delta Y in the final analysis is equal to MPC multiplied by delta Y minus delta T in brackets. We've just introduced changes to the consumption bit of our unified equation in terms of changes, or equilibrium condition in terms of changes. So if we solve for delta Y, it means we have to clear this bracket. We have delta MPC delta Y and MPC delta T. And then we take the term with delta Y to the other side, and then we factorize delta Y. We'll have delta Y being equal to, we'll have 1 minus MPC multiplied by delta Y, which is equal to the negative of marginal propensity to consume, because this taxation term has got a negative sign. The negative of MPC multiplied by delta T. So in the final analysis, we'll be having delta Y being equal to minus MPC over 1 minus MPC multiplied by delta T. The tax multiplier, as we can see, it's negative, because when taxes increase, it reduces national income. It's a withdrawal from the circular flow of national income. So the tax multiplier, the change in income is resulting from the change in income resulting from a dollar increase in T. It is delta Y over delta T, which is simply equal to minus MPC over 1 minus MPC, as we found in the previous slide. If the MPC is 0.8, then the tax multiplier is delta Y over delta T minus, which is equal to minus 0.8 all over, or over 1 minus 0.8, which is simply minus 0.8 divided by 0.2, which is equal to minus 4. In terms of the modulus, as you can see, the tax multiplier is smaller than the government spending multiplier. which in terms of modulus was 5. So the tax multiplier number 1 is negative. A tax increase reduces consumption, which reduces national income. It is greater than 1 in absolute terms when we ignore the sign. A change in taxation has a multiplier effect on national income, which is just in the opposite direction, or in a negative direction. But it is smaller in absolute terms than the government spending multiplier. Consumers save the fraction 1 minus MPC of a tax cut. So the initial boost in spending from a tax cut is smaller than from an equal increase in government expenditure. So you can use a graph of the Keynesian cross to show the effects of an increase in planned investment on the equilibrium level of national income or output. So when you increase investment, basically the impact is just the same as we experimented for government expenditure, because investment spending is an autonomous kind of expenditure. So the effect of increasing investment spending is just to bias upwards the planned or aggregate expenditure schedule, leading to a rise in national income. At this point, at a point which coincides with that point where my cursor is over. So firms increase output and income rises towards the new equilibrium, obviously taking into account the multiplier effect. Now, what is the IS curve? It's not a curve which shows a functional relationship, but it's a graph of all combinations of the interest rate and level of national income that results in a goods market equilibrium. So it's a graph which illustrates equilibrium points. The IS curve, it's a downward sloping graph which illustrates equilibrium points. Obviously, those equilibrium points, they coordinate your interest rate on the vertical axis and your real level of national income on the horizontal axis. What does this illustrate? It illustrates that actual expenditure output is equal to planned expenditure. It's like equilibrium points where the different planned expenditure schedules are intersecting the 45 degrees line in the Keynesian cross model for different interest rates. So now the equation of the IS curve is simply y, the level of national income, is equal to planned expenditures or aggregate expenditure. Recall that our consumption function was defined as C factor of y minus T, where y minus T is our disposable income. This is another way of saying consumption is a function of disposable income. And investment is no longer really exogenous. It's now determined within the context of the IS model or IS-LM model. Investment is determined by the prevailing interest rates or the average interest rate in the economy. And then we add government spending, since this is a closed economy. So to derive the IS curve graphically, we have the 45 degrees line where aggregate expenditure or planned expenditure is equal to Y. This planned expenditure is also called aggregate expenditure in some textbooks. And Y is called national income or real national income or real output or real GDP or whatever aggregate the author decides to use to identify national income. But along the 45 degrees line, aggregate expenditure or planned expenditure, as in this exposition based on N. Grigor Mankiwi's book, aggregate expenditure is called planned expenditure. along the 45 degrees line, we expect aggregate expenditure or planned expenditure to be equal to the available output. So the first schedule or the first curve is written associated with an interest rate of R1, which we mark out arbitrarily in the panel below or on the graph below. And then we mark out the equilibrium level of national income as Y1 in both graphs to come up with a coordinate in the lower graph. And then we say let the interest rate decrease. If the interest rate decreases, then we expect investment spending to increase. Given that interest rates they represent the opportunity cost of capital goods within an economy. So if the interest rate has gone down, it means capital has become cheaper, which incentivizes investment spending by firms. And this obviously yields a higher level of national income, because with more investment, we expect national income to experience this multiplied rise in accordance with the investment multiplier. So when we connect the 2 points that we have marked in the lower panel, we get to the IS curve, which is sloping downwards. Basically, R is not represented in the top panel of this graphical exposition. It's only displayed explicitly in the lower diagram, because that's where we want to derive the IS curve. Why is the IS curve negatively sloped? A fall in interest rates motivate firms to increase investment spending, as I've explained in the preceding slide. And this causes a total planned spending to increase. To restore equilibrium in the goods market, output, also known as actual expenditure, must increase. We expect output to increase to restore equilibrium. Fiscal policy and the IS curve. We can use the IS-LM model to see how fiscal policy, that is the fiscal policy variables G and T, affects aggregate demand and output. We'll start by using the Keynesian cross model to see how fiscal policy affects or shifts to the IS curve. So we start with our 45 degrees line where planned expenditures are equal to the real level of national income. And then we derive our equilibrium where PE equals to C plus I plus G, with those qualifiers like R1 and R1 and G1, where the PE curve intersects the 45 degrees line, we get the first equilibrium. And then any value of R, at any value of R, an increase in G will lead to an increase in planned expenditures, which leads to an increase in national income. So we say let government spending increase. When government expenditure increases, the interest rate is still R1 because there's nothing which has happened with the interest rate. So it means at the new level of expenditure, necessitated by an increase in government expenditure from G1 to G2, given that the interest rate has not increased, it stands to reason that we are operating on a higher IS curve, which is IS curve 2. So the horizontal distance of the IS shifts equal to delta Y is equal to 1 over 1 minus MPC multiplied by delta G, which is the government expenditure multiplier, which we covered earlier. So how about taxation? You can use the diagram of the Keynesian cross-allowable funds model to show how an increase in taxes shifts the IS curve. If you can determine the size of the shift. So at any value of R, if we increase taxation, it reduces aggregate consumption, aggregate household consumption expenditure. It gets reduced. So from C1 to C2, which shifts our aggregate expenditure function or our planned expenditure function from PC1 to from PEC1 to PEC2. That's the only way I can refer to this graph, to the top panel of the two graphs so that you understand. So the planned expenditure curve is shifting downwards parallel to itself. So we migrate from the initial equilibrium level Y1 to the final equilibrium level Y2, which means we are now operating on a lower IS curve as a result of some taxes being introduced in this economy, which act as a leakage from the circular flow of national income. The horizontal distance of the IS shifts equal to delta Y, which is equal to the tax multiplier, which is minus MPC over 1 minus MPC multiplied by delta T. So how about the theory of liquidity preference? This theory was propounded by John Maynard Keynes. It is a simple theory in which the interest rate is determined by money supply and money demand. The supply of real money balances is fixed because, again, it's a policy variable which is determined by the government through monetary authorities which are represented by the central or federal bank of a country. In the United States of America, the central bank is called the Federal Reserve System. In Zimbabwe, the central bank is called the Reserve Bank of Zimbabwe. So our real money balances which are supplied is simply nominal money supply divided by any proxy of the general price level. S stands for supply. It's a superscript to show us that we are looking at a money supply function, which is equal to M with a flat bar on top to show that things are fixed, divided by P with a flat bar on top to show again that things are fixed there. That neither nominal money supply nor the general price level are allowed to vary when we are calculating real money balances. So the graph of that simply shows that real money supply is just a vertical line. In other words, there's no relationship between the real money stock determined by the central bank and the interest rate which is prevailing in the economy. How about the demand for real money balances? The demand for real money balances, M over P, and then out of bracket superscript D to show that we are looking at money demand. It's simply liquidity preference, which is a function of the interest rate. We know there is the transactions motive, the precautionary motive, and the speculative motive. It's mainly because of the speculative motive that the money demand function is downward sloping. LR is the liquidity preference or money demand function. Where the money demand function or liquidity preference curve, which is blue here in color, intersects the money supply function, we've got equilibrium in the money markets. Equilibrium in the money markets occurs at a point where money supply, represented by M with a flat bar over P with a flat bar, is equal to LR, which is our money demand. At that point, the interest rate is R1, and the real money balances are M1 with a bar over P. In the case of the United States of America, an increase in the interest rate would necessitate a reduction in money supply. It would necessitate an increase, a reduction in money supply. Or it would be necessitated by a reduction in money supply if the government, through monetary authorities, wants to increase the interest rate. It simply reduces money supply, and then we migrate along the same downward sloping liquidity preference curve or money demand function, leading to a higher interest rate of R2. If we put Y back into the money demand function, we know that whilst liquidity preference has got an inverse relationship to the interest rate, it has a positive relationship to national income or with national income. We expect money demand to increase as national income increases, but the quantity of money holdings to decline as the interest rate increases. The LM curve is a graph of all combinations of the interest rate and Y that equate money supply and money demand. The equation for the LM curve, implicitly defined, is M over P with bars, which is equal to L, defined implicitly as a function of R and Y, where R is the interest rate and Y is the level of national income. Deriving the LM curve, the market for real money balances, and then we derive the LM curve. Initially, we say for a level of national income, Y1, we say let the interest rate be R1. And then real money balances are fixed by a government at M1 over P with bars obviously on top. And then we say let the level of national income increase. If it increases, it will increase the interest rate. So it stands to reason that a higher level of national income, Y2, is associated with a higher interest rate, R2, which is what is illustrated on panel B of our graphical exposition. So when we connect the 2 points, R1, Y1 R1 and Y2 R2, what we get is an upward sloping schedule, which is called the LM function. Why is it upward sloping? It is upward sloping because an increase in income raises money demand in an economy. When national income increases, you expect money demand to increase, for people to demand more money for transactions so that they are able to fully account for all the output which has increased in the economy. Since the supply of real balances is fixed, there is now excess demand in the money market at the initial interest rate, which will push interest rates upwards in a bid to restore equilibrium in the money market. So how money supply shifts the LM curve? We start with panel A, which shows our situation in the money markets, where the initial level of interest rates is R1 and real money holdings is M1 bar over P with a bar, which is that point on LM curve 1. And then we say let money supply decreased to M2 over P, which is associated with a higher interest rate. At the original level of national income, Y1, we have R2, which means technically speaking, we are no longer on the same LM curve. We are now on a higher LM curve, which is LM2. So we can conclude that when money supply is reduced, the LM curve shifts upwards. When money supply is increased, the LM curve shifts downwards, leading to a dynamic fall in interest rates for each and every level of output. Suppose a wave of credit card fraud cases causes consumers to use cash more frequently in transactions. We can use the liquidity preference model to show how such an event shifts the LM curve. We start with panel A, which shows our money market situation with an initial equilibrium of R1, M, 1 bar over P bar. And on panel B, we have got that point, that initial point on the LM curve, which is R1 and Y1. And then we say, let this credit card, whatever situation, the credit card fraud increase. If it increases, it forces people to demand real money balances in order to transact in this economy, which causes the LM curve to shift upwards. It becomes more costly to transact with cash because cash will be in high demand at the expense of other forms of payment like credit cards. So in the short run, we know that Y is equal to C of Y minus capital letter T plus I, which is determined by the interest rate, plus G, which is strictly exogenous. And this yields an downward sloping IS curve. Real money supply is equal to liquidity preference, which is a function of the interest rate and national income. So where the LM curve intersects the IS curve, we've got general equilibrium. It's equilibrium of the goods market represented by the IS curve and equilibrium of the money markets represented by the LM curve. So we have got a simultaneous money market and real goods market equilibrium. So in our next lecture, we are going to explore other aspects which are very critical in understanding the IS-LM model more holistically or in a more robust way by adding the BP part, which stands for the balance of payments, because all along we have been assuming an economy which is closed, which doesn't have an international or a foreign sector, an international trade or an international economic sector. But we know that that is unrealistic. So we'll add the BP part in my next installment of lectures. There is an illustrative example in these lines. I would want you to go through the working as you practice. First in deriving the IS curve, and then, and in deriving the LM curve, and then inserting the equilibrium condition so that you find the equilibrium interest rate and the equilibrium level of national income. So thank you so much, ladies and gentlemen, for watching this quick run through the presentation of the IS-LM model. I believe you benefited. So I'm going to share with you the slides. I'm obviously talking to my students at the National University of Science and Technology. These slides that I was presenting during the course of my lecture, I'm going to share with you through your emails. So thank you so much for watching the video of this lecture. I believe you benefit. If you were not able to understand something, you can always replay and until you understand whatever was being explained here. With the help of handouts and the detailed lecture notes as presented in my slides, you are able to go over the points that I covered in record speed. Thank you so much. We will meet in our next installment of lectures.